Hey guys, this is Rob. In this video, we are going to review an entire electrical set of drawings for a commercial 5-story apartment building that is currently under construction. We're going to go through each sheet and each detail of this drawing set to show you what is on a set of modern electrical blueprints. So stick around for some MEP Electrical education. This is a recent 5-story apartment building project that we designed and is under construction. And I'm going to go through this set of final electrical drawings sheet by sheet. There's 21 drawings in this set, and it covers both lighting and power. There's very little technology in this set. That was another designer that worked on that. Let me just cover this sheet by sheet to show you what we're looking at. Hang on, we're going to get kind of in the weeds on some of this stuff. We're going to look at every little detail, and I'm going to try to explain to you how this was put together. Now, first thing I'll jump into is this is what the building looks like. This is the architect's rendering, and you can see it's just a 5-story apartment building. There's some balconies here, and this first floor is a little higher than the rest, but that's what we're looking at. And then here is my sheet list. The drawings. We have a cover sheet, a site plan, and then floor plans level 1 through 5 that are lighting, and then level 1 through 5 power plans with a roof power plan. And then we have 3 drawings of enlarged unit plans, which will be the apartment units, each individually detailed out. We have enlarged electrical rooms detailed out, a one-line diagram, of course, and then some apartment loads and panel schedules, directories, load summaries to add up all the loads to feed this thing, and then panel schedules at the end. So that's kind of our table of contents for this electrical set. Symbol list. Now, some lists get large and some are smaller. This one didn't need a huge symbol list, but this just shows what our typical symbols are. Now, a lot of these you might say are kind of industry standard, but yet there are still little nuances from company to company, region to region. We try to keep things somewhat similar, but as long as you have it defined in this symbol list, then you can use that symbol in your project. But for example, we've got the good old 2x4 recessed light fixture. Used to be fluorescent. Now they're LED. We have a surface light, which looks like a rectangle with a little circle on the side. Recessed downlight is a square with a circle. And then the pendant light fixture is that rectangle, but the circle's in the middle. Exit sign, a disconnect switch, a fused safety disconnect switch. Equipment connection is this symbol, and then a motor has a little wings on it. A duplex receptacle. And even here, we're even giving some of the mounting heights for this stuff. A lot of the details of that would be elsewhere in a written specification, for example, or on some separate notes somewhere on the plans. So things are kind of scattered around. Here's a duplex receptacle above a counter, so it's filled in. Here's a quad receptacle or a double duplex. It looks like that, and this is similar above a counter. A panel board looks like that with this little door hanging out there. A junction box, emergency relays, floor receptacles, and then we get into the emergency light fixtures. We take a light fixture and we somehow get some filled in black to indicate that this is emergency. Now this one just happens to be a regular wall-mounted light, and this is its emergency counterpart. We got VFDs for variable frequency drives, motor starters, contactors, relays. You can see we have all these other symbols. Occupancy sensor for lighting, photocell sensor. So we have light switches that look like dollar signs. Sometimes we have a door controller to connect, GFI. Sometimes you'll see GFCI for ground fault circuit interrupter. We use GFI because sometimes we've had to use GFCI for government furnished contractor installed. And then we have weatherproof existing in parentheses, AFF for above finished floor, or AFG above finished grade. That's a common nomenclature. And then TYP for typical. Let me get over here to the lighting fixture schedule. Now this one's a bit abbreviated. Sometimes this is all filled in with more information. In this case, we had an interior designer that was helping to select the lights along with the architect, so we didn't have to get as specific here. But the basic idea on the light fixture is that each light fixture type or style gets a tag, a name. We have an NA, NB, NC. Now, N in this case, we had a couple buildings. This was the north building, so they put N in front of it, but it could just be an A, B, C, or D. L1, L2, L3. So some kind of way to identify the light. And then this table or schedule lets them know that with the lamp. Well, nowadays, most of this stuff is LED. How many lumens are we expecting to come out of this light? How much light comes out? The color temperature. This is in degrees Kelvin for if it's warm white, cool white, that kind of thing. What's the load in watts or VA for these lights? And then if we have a basis of design, we call it, where we want to pick one specific brand and model number, that this is what we like to see on the project, we will write that down here. For example, this one's called a landscape forms number profile column light, or an alphabet lighting number NU3RD series, etc. It gives the bidders, contractors, and everyone else looking at this an idea of what we have in mind. Some people will even add a little photograph of a picture on here to help. A lot of times this is open to other bidders. Other manufacturers can say, I have one that's similar or equal to this that I would like you to use on your project. But this establishes a quality and performance standard. And then we can try to describe it just for everyday layman's purposes. They can just read. If they don't have cut sheets for all of this, they can just see. For example, some of these are 4-foot pendant linears, a 6-inch diameter shallow surface. We just kind of give it an English description, generic description. And then if we want to get specific about the housing, for example, this one we wanted a white finish, and this one we want the glass to be white, but the finish to be dark oxidized. So we can get specific about colors and such. And then if we needed to, we could add things about the optics and the drivers, things like that. And sometimes we get a little more specific. Now, this is just a digital lighting control diagram that we use to show a generic control system. And this is the kind of control system where, for example, we have daylight sensors and aux sensors, along with a digital switch or dimmer. This is the little buttons you'd see on the wall. And that connects through a Cat5e cable, or even wireless, to a power pack relay that could even be a dimmer. And then here's the line voltage power. So this is showing how we have a low voltage or a digital lighting control, kind of a block diagram. And then the line voltage, this thicker line, comes out to feed the actual light fixtures. And then there's some dimming wiring also, this green line. So this just shows kind of a schematic of a generic digital lighting control and the parts and pieces that you may need. A vendor would take this and say, oh, I have a system called Nlight or called WattStopper that will do this. And I'm going to use my parts and pieces that make this work. So this is, like I say, a generic diagram to indicate the intent of the design to the bidders and the contractors. If you're finding this video helpful, I'd sure love it if you hit that like button down below. That will help spread it to other people that may find it useful. Also, if you want to see more of this in the future, you can subscribe to my channel, and I sure appreciate that. Thanks for watching. Now back to the video. This next sheet is a site plan, and site is like, the entire property that we're dealing with. It shows the building, and it shows other things outside of the building, mainly on this site plan. We have other plans for inside the building. So anything that's kind of outside the building, for example, in this parking area, we have a future EV charger. And even though this is a charge point, as we know, the charger's in the car, it's kind of a shortcut that we call these as a charger. But the idea here is that we need a 1.5-inch C as conduit, 1.5-inch conduit to this panel called HEV. That's the shorthand that's going on here. And it's just an arrow, and it tells the contractor, it's the future charger. We need to get a 1.5-inch conduit out here for that. Now, the details of where exactly that conduit will go, that's something that the contractor will field determine. He'll figure out in the field, because at the time of these plans, we may not know exactly where they want that. So we just have to at least say something to get it on here. But some of these details get figured out by the contractor in the field. This one here actually has wire in it. So we have the equipment connection. We have the panel circuit numbers. It's a 208 two-pole charge point. In fact, this building we'll find out is a 12208 three-phase building. And it needs number 2 wires. So this is telling them a little more detail of what's needed, because it's not future. It actually goes in now. So that's what's showing out here. And then we also show out here the pad mount transformer sitting out here. And this red is showing some clearance lines around it. This ends up being the face of the transformer. There's doors that open. And this shows the clearance needed around it from other non-combustible objects. And then we have a light. This is a light fixture. This circle here is kind of the concrete pole foundation for it, and then the light. The shorthand here is it says this is a fixture type NP1. That relates back to that fixture schedule. And NP1, if we take a look down here, NP1 right there is a Bega series LED parking lot fixture on a pole. So that's where that nomenclature comes in. So we have that, and it says it's connected to panel H1, circuits 8 and 10. So another 2-pole connection. This one here is 2 lights on 1 pole. And then we have a generator sitting out here in a landscaping area. And we're showing a rough path for its main power to get back to an electrical room that's in here. And we'll show the details of that later. But we're showing there's an underground generator feed and its accessories, and then the underground service lateral. We're trying to indicate that these should all come together, and we have a common trench, they call it, that brings that all back into the building. This just helps coordinate with, there's a lot of other utilities on this site, of course, which we don't show here. There's sewer lines, there's water lines, gas lines, all that kind of thing, low voltage lines out here underground that were coordinated behind the scenes so that we could indicate this path. We have more future chargers and another light. So again, this gives us an overview of the electrical out on the site. Now we get into the lighting of the first floor. You'll notice there's some blank spots. We don't cover the lighting inside apartment units. So if you can see here, this is a hallway. We come into a door, little closet. This comes in, and these rooms aren't labeled, but we'll have some enlarged apartment units later. But this shows us kind of a bedroom, and this is a bathroom. And we get down here to the kitchen and a living area, and another bedroom and a bathroom. So this is an apartment unit. And again, this is a north building, unit type D17.1. The architect gave each prototype, each style of room, its own kind of code, 2-bedroom. And ANSI A typically means that it's rated for handicapped access. But this is a 2-bedroom. This one right here is a studio. And this one here is a 1-bedroom. So you can see how these are delineated. Instead of showing the same lighting over and over for the same kind of units, we take each of these units and break them out onto that other sheet of enlarged, a bigger scale, because these right now are at 1/8 inch to the foot. We're going to break it out into a 1/4 inch to the foot so we can show a little more detail and it'll be less cluttered. But these plans show the lighting in the rest of the building, which I would call the common area or the house area. So as you can see, we get in from the parking area, and this is some of the covered parking. This shaded area is building above. And so we have lights underneath the second floor over this tuck under parking, they call it. So that's what's going on here. Now the filled in ones are emergency lights. You can see they're connected to an E1, which ends up being an emergency panel connected to that generator that we'll get into. There's a lot of codes and regulations around this as you get into the weeds that says, well, we need to have some emergency lights outside even now, not just inside the building to get you out. But once you're outside, we need to get people to a safe area away from the building. So there's often emergency lights out here. And you can even see we have an exit sign. This is the little circle with an X thing. That's an exit sign outside. You may see that in parking garages, etc. So we need to get people to a safe area. So that's what's going on here with this tuck under parking. And there's even a stairwell. This is stairs. You can't see the steps in this view. A stairwell coming down from above that has filled in lights, emergency lights, an exit sign to get you out of the building to safety. But the main entrance is kind of down in this area. This is the front corner you come in, and they call this a lobby. There's a little parcel area. So these are all the lights, and a lot of these, again, are picked out by architects, interior designers, lighting designers. We even get involved. It's definitely a collaboration on what kind of lights go in here, then how they're circuited. So we have some emergency lights filled in to get people out of the building, exit signs. There's some exterior sconces. So all these lights are shown in here, and they're shown to exactly what circuit each one goes to. This one's going to panel E1, circuit number 11. These are going to panel H1A, circuit 7. So that's what's going on here. And then similar for the next few levels, these are pretty much just corridors. Corridors and stairwells. Now these corridors are all darkened in fixtures. The entire corridor is emergency. Now as you get into lighting design, you realize that we may not need every light fixture on emergency to get enough foot candles, they call it, enough light. But a lot of times it's more economical to wire all of this to the same emergency panel, same circuits, to save some money. With LED, there's not a lot of power needed, so we can connect them to our generator without really increasing the size of our generator much because they're such a low wattage fixtures. So even the trash closer and this gas room, and this is you can't see it, but it's a data room in here, are connected to that emergency system. So all these lights are hooked up to the emergency system. And then these are just repeats. So all these floors are the same. So a lot of repetition. Now we also show some panels in here. There's a panel H5 up here on the 5th floor. 508 is the 5th floor electrical room. And we will show more what's going on in there. So that's the lighting. Then we get into the power plants. Now this, of course, has all of the receptacles and motors. Let's look again at a apartment. Now, in this case, we show a couple things. We're showing this little guy, and we oftentimes will have a little tag that says that this is the apartment unit panel. It's actually a load center style of panel, like you would have in your house. A lesser quality panel with plug-on circuit breakers instead of bolted-on circuit breakers. This is the load center that runs this apartment, and we're saying that it gets connected to MC1B. Well, that's a meter center 1B is the name of this meter center that has a utility meter so you can pay your power bill, and number 13. It also shows that we have a UEH 1500. It's a unit, apartment unit, electric heater is what that stands for in this case, 1500 watts. In this project, they needed us to show these electric heaters on the overall floor plans, as well as on the enlarged floor plans. So that's why these are here. But typically you won't see much in these units. And then in the rest of the building, we have more electric heaters in the stairwell. This is a water room. There's a 1,000-watt electric heater in the water room. Now this is all designed by the HVAC engineers. And they give us plans that tells us what they're putting in for heaters, and we just have to make sure we connect them properly. And then this is just a receptacle connected to panel H1, circuit 15. And it tells us there's 3 wires. There's a hot, a neutral, and a ground. And then you just go through room by room. There's a dog wash. We have a GFI receptacle in there and a heater. There's an exhaust fan. EF3 is an exhaust fan. And it just tells us what circuit these are all connected to. And then we get to the electrical room. And you'll see there's a little dash, kind of a dashed circular line around here that has this tag on here. This circle indicates that this is a detail. Number 1 on sheet EN 404, it's another sheet, has what ends up being an enlarged view of this area that includes these 2 rooms. So we will see this in an enlarged view. But even here, we can see that we have something called MDB, HDB. These are some of the distribution boards in this building. And we have some panels. These little guys, we have an E1 panel, H1 panel, and HEV panel. They're all in this room. And we have a few receptacles. And FACP is a fire alarm control panel. There's the connection for that to an emergency panel. So again, this just shows all of the connections in this building. In the water heater room, there's 4 water heaters, WHs. Now these end up being gas water heaters, so there's not a lot of power here. And we have CPs, which end up being circ pumps. Now we have another schedule that talks about all these equipment connections, which we will get to. And then we have a lot more receptacles. Down the hallway we have receptacles. In this case, we have ones that goes back to panel H1, which is right here, panel H1. And then it says up. Well, up means the circuit goes up to the next floor. There's some economy when you have receptacles that are stacked above each other floor by floor to running the circuiting up and down. If you figure there's only maybe 10 feet between floors, that's fairly economical versus trying to run my circuit all the way down this hallway. So, I mean, we have to go from here clear back to H1 first, but then from there on, we just go up to the rest of the receptacles. So that's one kind of circuiting technique we use. Something else that jumps out here. This is an apartment with a bathroom, but there's a little wall around here, and there's a little bit of a cavity they call a chase. FSD, that stands for fire smoke damper. It's part of the HVAC system, and they put a damper in the ductwork that shuts if you have fire or smoke, and it takes power to run it. So we have to connect those. As you can see, we connected that to a E1, an emergency panel, and then it goes up to more that are in this shaft. What else do we have in here? Bike storage. This has an exhaust fan and a couple receptacles. Looks like probably for e-bike charging. And we put a panel over here because we have a lot of circuits in this west end of the building. And instead of running the circuits all the way back into this electrical room, we found it economical to have a branch panel closer. So these go to H1A, not H1, but the A subscript, the ones that aren't emergency. Now the elevator, as you'll see, are an emergency on the generator. So we've put their receptacles that are in their pit of the hoistway. This is an elevator machine room that has power for the elevator cabs. So these are on emergency as well. Trash room, compactor. This is a overhead door right here. And so we have a door motor, trash door, and it's connected. That motor symbol with a little disconnect switch on it, and then standard receptacles. Now outside we have a receptacle, and we put WP for weatherproof and GF5 for ground fault. So it's a combination weatherproof ground fault type of receptacle because it's outside exposed to a wet environment. And then HP1 ends up being a heat pump, and it's sitting outside also, so it needs power. And this receptacle is nearby, so you can service that heat pump. Here's more of that lobby we were talking about, just some receptacles around the outside. There's a sign in the canopy that is connected, and we sometimes put little notes that goes via the lighting control relay, is what that's saying. So we want this sign to be controlled with the rest of the lighting through a relay system. We have the parcel room in here. It's got a fan coil unit, FC1. There's some motorized dampers. So anyway, a lot of HVAC equipment, it has to be connected. And then we have a little mail area and a little restroom. So this area here, we've got a coffee maker and a TV that we had to connect. So you can see all the connections are on here. And the ones on the west end are going back to that H1A. And then up here we have a couple more live work units that again will be detailed. You can see there's the call out for the enlarged views. Now second floor, a lot of the same. It's mainly just a corridor. There's our fire smoke dampers again going up through that chase. We have all of our apartment units all fed back to a meter center. We have this electrical room here that gets enlarged to EN404, which we'll get into. We have our receptacle in the hallway that's going up and down in this case. The circuit's feeding up and down. So that's what's going on here. More information here at this IDF data room. So that's similar for the rest of these plans. Now, what I will note here is on the 5th floor, we have this H5. It was economical to have another branch panel way up here on the 5th floor to handle some of these receptacles that are kind of on this whole west wing. It will, as you'll see, it also serves equipment on the roof. For example, up here, this is our roof plan. And there's not a lot up here. It's pretty much just an open roof. But this is kind of above the elevators. They call it an elevator overrun. There's an exhaust fan up here that's connected to the emergency panel. We've got some weatherproof GFI receptacles up here. We have a RTU, which is a rooftop unit up here. It's a 3-phase, as you can see by this home run. And it goes to that panel H5. That panel H5 that's just right below here. So you can see we put H5 so we don't have to go all the way down to the first floor and over. We can just run it all along, same here, all along this top floor of the building to feed these circuits. Now here are the enlarged apartment units. We have 3 sheets of these because there's that many different style of units. And each different style of unit, we need to show a layout so that the installers know the difference. So for example, let's start with our little studio. This is like, maybe you live in a small house, or maybe you live in an apartment. This is what's going on in here. We've got receptacles throughout the living area. We have a PTHP, which is the heating ventilating unit. And then receptacle in this closet, there's actually a media panel, smart panel in here that has your internet connection, things like that. So that's in here, so it needs power. Maybe there's a router. And then in the restroom, this apartment has a washer and dryer stacked into this little cubby right here. So we have to get connection for those. You can see we called the dryer out to be a 30 amp connection. We have a light above the sink. These apartment unit plans contain both lighting and power in this case. Sometimes we will separate them, but in this case, we put them both on one plan. Here's the unit load center or unit panel right there. So everything in this unit feeds to that, just like a house. We've got more lights in here, and they all have a type. These are all unit lights. So they have a UA and a UB. There's a little exhaust fan. It's controlled by a switch. The switch controls the light. And then we have some under counter lighting. And then this is the kitchen. So we've got receptacles for the microwave, refrigerator. These are above counter receptacles, the filled in ones. Under the sink, we have a disposal with a switch. We have the hood fan connected. We have the range, which is a 50 amp receptacle. And then we have light switches. Now these here, when you have 2 switches, they end up being like a 3-way light switch. And then this is just a single light switch to switch off a receptacle by the bed. Now the actual circuiting of these is shown elsewhere, which I'll show you. Instead of circuiting each one of these with circuit numbers, we let the panel schedule dictate that. There's another studio, and it's different because this is actually a little patio outside. So there's a wall mount. You can see a little wall bracket. There's a wall mount light here, and a receptacle under it. Otherwise, it's very similar. So each of these is just laid out for the floor plan that the architects designed. This one has the dryer and washer out here in a closet. Now, we don't decide where this stuff goes. The architect gets to do that with the owner, but we just have to react to it. So there's a number of different studios. 1, 2, 3, 4, 5, 6, 7, 8, 9 different studio layouts that we had to show. Then we get into, this is a 1BR, 1 bedroom. And you can see here this ends up being kind of a barn door into the bedroom. We have the unit heater in here for its heat. The rest of the area gets heated and cooled with this PTHP. But as you can see, it's the same thing over and over for each unit. So we have 3 sheets of that. Let's take a look at one of the larger rooms. Here's a 2-bedroom. Again, come in the main door, got some lighting, washer and dryer stacked, bathroom, bedroom. In this case, we are switching 2 of the outlets, and we end up switching half of the outlet, if you've ever seen that. It's called a split bus receptacle, where we can just switch half of the receptacle to turn lights on and off because there's no ceiling mounted light in here. And then PTHPs over here, and again, receptacles around the walls. This one has an island with the microwave, disposal, dishwasher out here in the middle. So we had to show receptacles for all that. But that's what's going on with the apartment units. And each of those are connected to a panel or a load center, which, as you saw on the overall plan, we tell them where each of those gets connected to the meter center. Now, these are enlarged views of the electrical rooms. And a lot of times we will show these enlarged because they get fairly busy. We can show more detail. For example, this one here, MDB stands for the main distribution board, HDB, house distribution board. And on the one-line diagram, we'll see what those look like diagrammatically, but they're big boxes that sit here in this room. We have ATS, the automatic transfer switch for the generator emergency system is right here. We have the emergency panel, E1, a house panel, H1, and a house EV, electrical vehicle panel right here. Bus duct above. This is using, instead of just conduit and wires, we're using an enclosed bus duct that extends out of this distribution board and goes over here, and there's a bus duct riser, goes up inside this room to feed upper floors. Upper floors can tap into that bus with a disconnect or actually a whole meter center. So that's how power is distributed, and we'll show you that on the one-line diagram. And then we have the meter center, 1B is in here, and then just some receptacles. This is just showing in a large view of what's going on in this electrical room. And then other electrical rooms, 208, there's an electrical room on the second floor. This shows meter center 2A is in here, and it has equipment and meters that go around the walls. Another electrical room, meter center 2B. The bus duct riser comes up through here, and this gets tapped into these meter centers, which I'll show you on the one-line diagram. In this case, we just have some conduit risers coming up through electrical rooms. So these enlarged plans just kind of show what's going on in each room. And, things can be measured. We can make sure we have clearance in front of here. The utility takes a look at this to make sure that we have enough clearance for their meters because they're going to be in there reading them. And then here we go. The one-line diagram, which really is a powerful tool to summarize the electrical distribution system. So I'll tell you a couple things here. We have the one-line diagram itself. We have a detail up here, which is called the grounding system with generator detail. We'll get into that. And then we have what's over here called feeder schedules, copper and aluminum. There's a shorthand here to tell the contractor what size conduit and wire to use for these different feeders. For example, a 20-2 is a 20 amp capacity 2-wire plus ground feeder. It needs a 1/2-inch conduit, 2 number 12s in there, and a number 12 ground. So that's the shorthand for that feeder. If we need a 95 amp feeder, now this is 95 amps is what these number 2s are rated for at all of the right temperature ratings and things like that. So this is a 95 amp feeder. It's a 1.25 inch conduit, 2 number 2s, copper, and a number 8 ground. This is all done per codes, but this is the whole chart. You start getting here to some of these large aluminum feeders. Let's see, maybe we need a 2000 amp. Ends up being a 2040 amp feeder. It's 6 4-inch conduits. Each of these has 4 600 kcm, 1000 circular mil, used to be MCM, huge wires, and each of them has a 400, another large wire, 1000 circular mil ground wire. As you can see, we get all the way from a 20 amp little 2-wire circuit all the way up to these 3060 amp feeders. Now we get to the one-line diagram. This is shown in levels. Level 1 down here, level 2, level 3, level 4, level 5, and even the roof. So we've got it shown vertically to help understand the topology of this. And the basics of this, understanding one lines is a whole lesson in itself, and I'll be covering more of this in future videos. But to give you a basic rundown, let us start at the end. I like to start at the end and work my way up to the top. So, for example, we had that apartment panel. Let's say right here, load center. That's my little apartment panel like you have in your house. It's typical of 15 on this floor. There's 15 of these on this floor, and I only show one. There's 14 others that we don't show because it would get too busy. But it is fed from a 125 amp 2-pole circuit breaker. Now your house, typically, if it's older, it might only be 100. If it's newer, it might be 200. These apartments, it only takes a 125 amp feed. And there's an M, that's a utility meter for reading your energy use. So this meter center, MC, this ended up being 4B, it's on the 4th floor, is an 800 amp rated big meter center that has, in this case, 30 meters lined up in it. And each of those meters is a meter and a main that feeds each of these apartments. So all these apartments on this floor and then on that floor is 15 more feed it from this meter center. Now this is telling them what size feeder to put in. A 1/0 number 4 ground MC cable for these feeders, metal clad cable. This meter center is protected by an 800 amp main breaker. Now it is fed by this black line here, which is called over here bus duct riser BB, bus cable BA. So we have a bus duct that is 1200 amp rated, which goes up through the building and lets these tap off of it. And it comes down here, and that riser was fed from a 1200 amp, which is connected to a 3500 amp bus main distribution board. Here's some more meter centers. As you can see, for the other apartment units, the other floors, they're all attached. This is 1000 amp rated, 800 amp rated. They are attached to this 1600 amp bus, and that's attached to this. Then we have things like, here's a 400 amp feed. If you can read, it goes way over here to another meter center, 1B. And this feeds 13 units at 125. So you can see these apartment units are scattered amongst these different meter centers throughout the building, instead of all coming down to one giant meter center on the first floor, which we've done buildings that do that. But in this case, it was more economical to break it up into individual meter centers on each floor, reduces the size of all these smaller feeds, and it's more economical to feed each of these with the larger feed. Also has to do with how much space you have in your building. So a lot of these things go into consideration for laying this out. But this is how this one ended up. The other things we have is up here on the roof. Elevator A, elevator B. These are elevators. And you can see we have the amp draw, full load amps, and the accelerating amps. They're at 208 3-phase. There's elevator controllers. There's a fuse switch. And those are fed clear down here from this panel E1. You can see we have a breaker feeding each of those. SPD stands for surge protection device. So this has surge protector because it's an emergency system. This emergency panel is pretty much a 200 amp feed through a 200 amp automatic transfer switch. As you can see, the feed to this is either hooked up to the generator. Here's a generator. It's a 30 kilowatt 208 123 phase generator with a diesel generator with a sub-base fuel tank and a 100 amp breaker out of that, which ends up feeding this transfer switch. Now the normal feed is a 200 amp feed coming from the house distribution panel. Now one question that comes up is, well, if anyone's noticed, I've only got 100 amps worth of generator feed. Why? What's going on with this 200 amp stuff? Well, the note that I quickly went over up here is this. Note, the elevators are non-simultaneous when on the generator power. And also we have a braking regen note, which I'll have to cover in a future video. But the idea is that the elevator controller monitors the emergency system, and it knows when we're on generator power, and it restricts use of only one of these two elevators at a time simultaneously when we're on generator. So the generator feed and capacity only have to be able to handle one of those elevators, as well as we actually have some emergency lighting connected to E1, which is a small load compared to the elevators. But the idea is that this generator only has to handle the emergency lighting and one elevator when we're on generator. But under normal power, we need the full 200 amps. That is why this feed from normal utility power and the transfer switch and the panel, everything's rated for the full 200 amps because in normal situation, they can both run. That's how that works. This is the house distribution panel. The reason the house distribution panel is its own bus fed with its own breaker and its own meter is for that reason. We want this metered separately from the apartment units, which have their own meters up at the meter center. Other house loads are we have an EV panel, it's a full 600 amp, and then we have what we call the house panels, which are feeding the lobby and the mailroom and the corridors, corridor receptacles, things like that. That only needed 200 amp. And as we saw, we had the H1 in the electrical room, the H1A was over on the west end. And they are both just fed with a screw lugs that feeds this second panel. They're just fed with a 225 amp feed. And then we have this 100 amp feed here. Where does that go? This goes way up here to that panel H5 that we saw up on the 5th floor, mainly to feed the roof. So that's what's going on there. And then we have a 100 amp breaker in here for a future solar connection. And that would all be done by a solar specialty firm. But we have a feed into our house distribution panel from that solar for future. So that's all that gets fed from the apartments, from the receptacles, all the way down to the main board. And the main board is fed from the pad mount transformer that the utility sets. And this is its secondary feed. And then this ends up being its primary feed to the transformer. Comes from a volt. A 5106 is the type of volt it comes from. So that's what's going on here. Now, this piece here, 43,298 amps symmetrical. This is the available fault current. If we have a short circuit here that they call it a bolted fault where all three phases get connected together, short circuit, calculations based upon this transformer size, based upon the entire utility system, based upon this wire, says we could have 43,000 amps as a short circuit. Well, our board's only rated for 3,500 amps. So as you can see, this fault current can be 10 to 20 times larger than the actual rating. So this all has to be able to handle that large surge, if you will, of current. That's what's going on here. Okay, we can move on. These are the load summaries, load calcs, and panel directories for the apartment units. For example, typical dwelling unit calculation. Now, codes are very picky about how we add up the loads in a dwelling unit, apartment, or your house. Like it says here, unit calculated load per the NEC, National Electrical Code 220.40. So there's a number of different calculations. This is one we use for most typically. It has to do with the area of the unit. This is a live-work unit, the area, and it has the loads. And it tells us piece by piece how to add up all the loads. For example, the general lighting load, it includes receptacles, lighting receptacle load, is 3 VA or watts, 3 watts per square foot, times the 924 is that. Small appliance loads in your kitchen, it requires to have 2 circuits, calculated at 1,500 watts each, or VA each, there's 3,000. The dryer's 5,000, the washer. So here's all these loads in your house, get added up. So the total general load is here. And then it allows some diversity of that. It says we only need to take the first 10,000 watts or 10,000 VA of the general load at 100%. The rest of it above 10,000 only has to be at 40%. So here we have 23,822. The first 10 is full. The rest, which would be 13,822, is taken at 40%. And that's how we get 5529. So they realize that you're not going to have everything on all at the same time. We ended up with 15. On top of that, we have no heat pump, but we do have a 2,800 watts of that heating unit. And make us add that, because that can be running all the time for at least 3 hours. And that gets our total load. And if you convert that into a 208 volt single phase, you get 88 amps. So 88 amps to run that one live work unit. And so we can feed it by a 125 amp. We could probably feed it with 100 amp too if we want to save a little money. That's how that works. So we do that for each kind of apartment unit. Here's the 2-bedroom. This is the big guy. 1,088. And we pretty much take like the largest unit to get a typical here. And we do the same thing. This guy has more heating, 4,300 watts of PTHP and electric heat. So all that adds up. So this one is a 96 amps load, which still fits in a 125 amp service. So that's what's going on here. And you get down to the studio. It's only 415 square feet, little guy. And it only draws 78 amps. But you can see, based on the size of the room, based on the heating, this is what we have for the loads. That's loads. Now, the other half of this is the circuit breakers in the load center or panel. Again, like your house. Your house would be 12240 single phase. But in commercial, when we have a large enough building, we need 208 three-phase. And so we feed the units at single phase 12208. Bus rate 125 amp bus. There's a main circuit breaker in this case. Sometimes there's not. But this says description down here, a breaker here, the circuit number, the phase it's connected to, and the circuit number. This is 2 columns. So this guy here is 1 circuit right there. This guy here, 1 circuit. So the dishwasher, 15 amp single pole breaker on circuit 5. The disposal, 15 on circuit 7. The microwave and hood, we want a 20 amp breaker. And the smoke detector, lights and plugs, we put those on a 20 amp breaker. The dryer, right here, this takes up 2 poles. So circuits 19 and 21 are a 30 amp 2-pole dryer outlet. The washer is just a 20. And then over here, let's go over to the range. The range, 2 poles, 50 amp 2-pole. So this just shows all the breakers. And then we have to have GFCI on some of these and arc fault breakers on some of these. So that's what's going on here. So this just shows the contractor, the builder, what circuit breakers we have. This is a 24 circuit panel. And this is, again, similar to your house. Then we get to the commercial panels. And this, we start out with the main switchboard MDB, the big guy. It's 12208Y, 3-phase 4-wire system. It's rated at 3,500. And this has the 4 breakers we saw on the one line. These are the 4 feeds. We have a bus duct riser, BA, BB, a meter center 1B, and the house distribution board. This has all of the loads in VA, adds them all up, and then down at the bottom, and this is all done in Revit software, it adds up by category all of the loads and applies the demand factors according to the NEC. Some of these are less than 100%, some of these are bigger than 100%. It depends on the load. When you have 2 elevators, you can knock it down to 95%. When you have this many receptacles, it gets knocked down to 84%. So this applies demand factors. Even EV chargers in Oregon have a demand factor that's better than what the NEC says. This adds it all up, and it says here that our estimated demand on this is 3,179 amps. Therefore, it fits on a 3,500 amp board. But then we have the HDB, house distribution panel. Again, it has all of its panels, all of its loads, broken down by classification with the proper demand factors, and it says 706 amps on this 800 amp board. Same thing with the bus risers. So everything is just itemized here to show the plans examiner, inspectors who review these for code worthiness, that we're all above board with our sizing. Here's a meter center. Every unit called out with its connected load gets all added up at the bottom. There's connected wise, if you just add up all the connected loads without applying any diversity to it, we have 2,800 amps on this board. But per the NEC, because we have so many, we have 40 units connected here, they let us take a 28% demand factor on that because they know that not everybody can have every load on all at the same time in an apartment complex. And that puts us down to only 807 amps needed on this board. And it's a 1,000 amp board. So that's how it's going on here. This meter center 2B has fewer units, only 30. And it doesn't quite get the same demand factor, 33%, but we're still only 697 amps on this 800 amp board. So that's what's going on here. And then some standard panels. For example, H1 is a standard panel board with A, B, and C phases. We have circuits 1 through 41 here, odds, and 2 through 42 evens. And this just shows circuit by circuit what the breaker should be, what the loads are, adds them all up by phase, adds them up by category, classification, applies the right demand factors, and here we go with our total demand. But it's circuit by circuit. And then we have this mechanical equipment connection schedule, which I was saying has the HVAC equipment and plumbing equipment called out by mark number. So that ties into the floor plan, like EF1's an exhaust fan, EH, electric heater. A DS stands for ductless split system, I for indoor unit, O for outdoor unit. What the electrical characteristics are, what panel it gets connected to. And for example, this indoor split system gets fed from the outdoor unit. Electric heaters, air handling units, heat pump units, packaged gas electric rooftop units, gas water heaters. They have a small 100 VA load. And then over here, the feeder, we use that shorthand again, a 55 amp 2-wire feeder. And we can look that up on our schedule. This one needs a 20 amp 2-wire feeder, and we can look that up on that feeder schedule. And here's our emergency panel, just to complete it. A lot of it's emergency lighting, elevator cabs, elevator room, even the elevators are on here. And again, when on generator, the calculated load decreases to this since only one elevator will operate at a time. So there is your overall summary of a complete set of electrical drawings for this commercial multifamily apartment unit. I'll be doing more of these reviews in the future, so stay tuned. Thanks for watching.